Hi, today we're going to be talking about the biochemical process of alkaline hydrolysis, which is also sometimes called liquid cremation. This process involves putting a body into a solution of 95% water and 5% potassium hydroxide. Potassium hydroxide is just the chemical name for lye. In order to understand the biochemical process, it's first important to look at the tissues that make up the body. There are four main types of tissues in the body. These are the epithelial, or the skin and the glands, the connective, which is cartilage and bone, the muscle, and then the nervous tissues. It's also important to understand the components that make up the body. Our bodies are made up of over 50% water. The next largest group is proteins, and then minerals, which are found in our blood and bones. The next largest group is fat. Depending on the person, fat can make up anywhere from about 5 to about 32% of the body. Before we can get started, there are also some definitions that I need to explain first. The first of these is alkaline. This just means basic, or a solution that has a pH of above 7. The next definition is hydrolysis, which just means that we are breaking the compound's bonds using water. For this video, we will be looking at fat breakdown using alkaline hydrolysis. This process is known as saponification. This happens when fat is broken down using either potassium hydroxide or sodium hydroxide. Interestingly, this mechanism is given its name because at the end it actually produces a soap. There are 3 steps to the saponification mechanism. I'll give you a little bit of an overview right now and we will go over them more in depth later. The first step is a nucleophilic attack that is done by the hydroxide. The next is a leaving group removal, and the third is the deprotonation. Looking at our starting reaction, we start with a fatty acid and lye, and we're going to be making glycerol in a soft soap. A soft soap is made because we're using lye. If we were using sodium hydroxide, it would just be called a hard soap. To start out our reaction, we start with a triglyceride or a fatty acid. This is what we will add the potassium hydroxide to, and it just represents any fat that we have in our bodies that will be broken down by this process. The R group here just indicates that it's kind of a skeleton triglyceride. It's not a specific one. This is what we do when we don't want to draw an entire molecule in chemistry. So what we're going to be doing is breaking the ester bonds of the triglyceride, which are indicated by the green marker, and this is what an ester group looks like. Just for clarity and a lack of confusion, the part that is being circled in green is going to be known as OR, and it will be written in green, but just to kind of take up less space, that's how it will be indicated. When we begin our reaction, this is how it looks, and our nucleophile at the bottom is our OH group, and this just means that it likes areas where there aren't a lot of electrons. So it comes from the potassium hydroxide at the top, and that oxygen molecule is just going to go and attack the carbon and bind to it. This is going to cause carbon to have more electrons than it needs, so the double bond, the electrons in that double bond will go on to the oxygen at the top. This is the intermediate that's formed when all of that happens, and it is an intermediate, which means it's not stable, and that means that it's not going to want to stay in this position for any longer than it has to. So the electrons from that top are going to go into a double bond again, and this is going to create too many electrons on the carbon, so it's going to cause our OR group to leave or detach. This is what our leaving group looks like when it detaches, so here you can see that we have 2 separate compounds. In our last and final step, deprotonation occurs. This means that the proton from our hydrogen atom leaves the group and goes on to our OR group in order to make it neutral and not negative. Here's a little overview of the steps that we just went over. Once this is done, the fatty acid is broken down into what would be a liquid. In the case of a human body, this would mean that it's no longer in a solid form and the fat at least would be all the way digested. I hope you found this video informative and interesting. Thank you so much for watching.